GATE 2020 Civil Engineering question number 36 set 1. Question says that a water flows at a rate of 12 meter cube per second in a 6 meter wide rectangular channel. A hydraulic jump is formed in a channel at a point where the upstream depth is 30 centimeter just before the jump. Considering acceleration due to gravity is 9.81 meter cube per second and density of water is 1000 kg per meter cube, the energy loss in the jump is. He is asking energy loss. For this question you can refer to this NPTEL video lecture. So let us understand what's the question is saying. You know what is hydraulic jump. This is a hydraulic jump formation animation, or you can say a picture. So they have given a initial depth as a 0.3 meter. You can see here upstream depth is as a 30 centimeter before the jump. After that hydraulic jumps happen, and this is downstream side depth, that is y2. So he is given acceleration due to gravity as well as density of water, and he is asking head loss, right? So there are some formulas which are required in order to solve this question. First formula is Froude number formula. Second formula is kind of taken from a derivation, that is a Bellinger's momentum equation for rectangular channel. After that head loss, that is the third formula which will be required, and last formula which will give our answer for this question, that is a power lost in a jump, or a energy loss in a jump, right? So we have to calculate each and every value from this formula. After that, end of the this PPT, you will get your final answer. Let's try to solve the question, right? So the first the formula which we will be using will be Froude's number. For Froude's number we will require Q is nothing but a discharge per width. So discharge they have given us 12 meter cube per second, and width given as a 6, and it will come out to be 2 meter cube per second per meter, because this is a discharge per meter or discharge per width. So initial Froude number before the jump will be, initial Froude number will be, the formula for Froude number is Q square divided by G into Y. So it is upstream side, so y1 cube and whole power 1 by 2 or 0.5. So calculate this. So our Q is 2, right? After that 9.81, that is acceleration due to gravity. After that y1 is given as it's 30 centimeter, that is 0.3 meters, and whole bracket to the power 1 by 2, right? After solving this equation we will get the answer is 3.88 as a Froude's number, initial Froude number, right? So this is time to use our second equation, that is this Bellinger's equation, right? So putting the value, that is y2 upon y1 equals to 1 by 2. I will write in a quite bigger form so you can see clearly. I don't know till now this were visible or not, but from onwards I will write in bigger font. So the equation is 1 upon 8 into FR1 square and bracket close. Putting the values 1 by 2, so minus 1 plus under root 1 plus 8 into FR1 is 3.88 square of this, bracket close. So this uh, this will come out to be 5.0018, 5.018. So y2 will be 5.018 into 5.018 into this y1, right? This y1, this will come towards this side. So y1 is nothing but 0.3. So our y2 will come out to be 1.1. Our y2 will come out to be 1.505 meters, right? After that we have to calculate head loss, right? We have to calculate head loss. So head loss, this font will be sufficient, I guess. Head loss will be y2 minus y1 upon 4 y1 into y2, and this upper brackets cube. This is formula for head loss in hydraulic jump. In order to solve this question, you must be you should remember this all formula. So we just calculated y2 1.505 minus 0.3, right? So bracket cube divided by 4y1 into y2. This is 0.3. So this will come out to be 0.968, right? So yeah, you should check your answers with calculator and try to get calculator only. Now the last thing for which we have done this much of a calculation: power lost in a jump, or energy lost, or energy loss. You can say that energy loss is equal to gamma of water, that is density of water, into discharge into head loss, that is nothing but HL. So it will come out to be 9.81 density of water, discharge is 12 meter cube per second, and head loss is 0.968. Just we have 968, just we have calculator. By solving this, our answer will come out to be 114.04 kilowatt. This is our answer, energy loss, right? So remember unit of this specific density, unit of this discharge, and unit of this head loss, right? So writing in finding our answer in options will be 114.04 kilowatt. Answer will be option A. So this difference is due to the calculations. Sometimes we use 9.81, some people will use 9.8 only. So that kind of small difference is okay here, because answers unit are very different for every options. Only this numerical 114 is given here in second option, but it is in megawatt. So our correct answer is option number A. Thank you.